In a non-ideal transformer, the only difference is that the power on the primary side is not conserved when you come to the power on the secondary side. You basically lose some power in the whole process of this stepping up or stepping down. And so what we need to understand now is, why does this happen? And what kind of equations can we still use? Well, there are essentially three main sources of power loss. Number one, coil resistance. One of the most difficult things to avoid is the fact that these transformer coils over here are especially thick, and therefore they have significant resistance. And of course, if there's resistance, you will dissipate heat, I squared R, in these coils, and that is one source of power loss. And okay, what is the next one? Well, another form of power loss is in something called eddy currents. Now, in the A-level syllabus, you don't really have to know what eddy currents are, but basically when you have a huge amount of changing flux in something like iron, it is quite inevitable that you're going to induce some of these currents because, well, iron is a conducting material. And so these eddy currents tend to look a little bit like that. Right? They go in circles like this. And once again, when you have currents in something like iron, you're going to have a heating effect, Joule heating. And so again, that's an I squared R kind of thing, and you're going to be losing energy from that. Now, the third one is in something called magnetic flux leakage. And this arises because you are supposed to assume that all the flux that is created on the primary side makes its way successfully across to the secondary side, and you don't lose any of this flux. But in reality, what happens is that some of this flux will come here, and whoops, okay, there you go. A little bit goes out there, a little bit goes out there. We try to minimize this effect by using iron as the core, but still it's inevitable that some of this will happen. And so, what do we need to understand? Well, NP over NS equals to VP over VS is okay as long as the flux in the coil, or rather in the iron core, is conserved, as we have seen before. And so, if the question is very clear that one of these is the source of your power loss, then this equation is absolutely fine. But if it becomes evident that one of the sources of power loss is in flux leakage, and unfortunately, this equation is not appropriate either. And so that means you don't really have any equations to study this non-ideal transformer if the power loss is due to flux leakage. So one of the ways that we minimize one of these things, the eddy currents, is through a process known as lamination. So let me just write that down. Okay, so when you say you laminate the core, it means you cut all these little lines like this. And basically what you're trying to do, you're trying to make it more difficult for eddy currents to flow. Right? And so lamination reduces your eddy currents, and so it makes your transformer more efficient.